Okay? But we are not talking about the eukaryotic cells, so just don't worry about it. So this is all in all about respiration. The last part in this chapter is all about the other aspect, which is the fermentation. And it is usually done by organisms that do not respire, or they are evolved not to use the respiratory pathway, so there is no oxygen usage. And the ATP synthesized is only during the glycolysis step, so there is a very low yield of ATP in bacteria undergoing fermentation. So bacteria that undergoes fermentation, there is a low ATP yield. And when it undergoes fermentation, this pathway is the more dominant one. There is no Krebs cycle, there is no electron transport chain, there is no transition reaction. Because all those reactions, they do not participate in fermentation process. So no transition reaction, no Krebs cycle, no electron transport chain. Then the terminal electron acceptor in the fermentation pathway is always an organic molecule. Unlike in respiration, which is an inorganic molecule, in fermentation it is always an organic molecule. And the organic molecules are usually either the pyruvate or a derivative of pyruvate, which could be the acetaldehyde. If pyruvate accepts the electron from the NADH to regenerate the NAD, then it will form lactic acid. If it is a derivative of pyruvate, the pyruvate would undergo decarboxylation to form the acetaldehyde, and that acetaldehyde will now accept the electron to form NAD in the process. It would generate the ethyl alcohol. So this is the thing about the fermentation pathway. And sometimes the end product of the fermentation pathway, they are used for the identification. They are identification of bacteria. Some of them are the commercially important products. Just think about it, like the lactic acid which is generated, that lactic acid is the main source for the flavor of the cheddar cheese. Swiss cheese, the flavor of the Swiss cheese is because of the propionic acid, which is the end product of the propionibacterium. So some of the lactobacilli makes the lactic acid that is used for making the Swiss cheese. The propionibacterium is used for the typical flavor of the Swiss cheese. And that hole is because the hole that are made is mainly because of the gas which is being released that makes up the hole. Some of these, they also make what is called as the soy sauce. The soy sauce, what you normally use as a flavoring agent. Guess what? Soy sauce is just the poop and pee of bacteria. But it is used, we use it as a flavoring agent. But in all reality, it's just a metabolic waste, or what I call it is a poop and pee. Pipe cycle. Some of the bacteria you don't have to know about. You just have to know the lactobacillus, the propionibacterium, the yeast. The yeast, when they undergo fermentation, it generates ethanol, and that's how the grape juice is fermented to make the alcohol. The Saccharomyces is yeast. Some of the Clostridium bacteria, when they ferment, like it causes gangrene. And gangrene is because of some of the fermentation product of the Clostridium, and that causes tissue death. So the death of tissue with the Clostridium or in gangrene, in gas gangrene, is because of some of the fermentative product of the Clostridium, and that Clostridium end products are toxic, and that's how it causes what we call as gas gangrene and cell death. So oftentimes Clostridium, some of the Clostridium are associated with the gangrene and cell death. So here, sometimes you have infection with the Clostridium infection, and that causes gangrene and tissue necrosis. This is because it causes gangrene and tissue necrosis. This gangrene is because of the fermentation in products, which are toxics. There are some bacteria which are able to ferment the glucose but not the lactose. Some bacteria, they only ferment the lactose and the sucrose, like the E. coli. Yeah. So if you want to get into a little bit more, the Clostridium perfringens, P-E-R-F-R-I-N-G-E-N-S, Clostridium perfringens. So this is the one, some of the fermentation end product of this bacteria is the one that causes tissue death. That's the one that causes tissue death because some of the fermentation end products are toxic to the tissue and it causes that gas gangrene. Alrighty, folks? One of the reasons why the NADH has to be replenished during the fermentation process, the NAD has to be replenished. Otherwise, if this NAD is not replenished during the process of glycolysis, all the NAD will be reduced to NADH, and then even the glycolysis step will be stopped. The NAD is getting reduced to NADH, and in the process is making some ATP. And if all the NAD is reduced to NADH, there won't be any ATP formation because you are going to exhaust the source of NAD. So what the fermentation does, it again regenerates the NAD or it oxidizes the NADH. That way, the fermentation has only source of ATP is the glycolysis pathway. It keeps the glycolysis steps always going on. There are some bacteria which ferments the glucose but not the lactose, and some bacteria ferment both the glucose and lactose. Like Proteus species, they ferment glucose but not the lactose or the sucrose. They ferment glucose but not lactose, Whereas there are some other bacteria, the other bacteria like E. coli and Enterobacter. They ferment, they ferment lactose and sucrose. They're from lactose, sucrose, as well as glucose. And lastly, folks, the very last two part, in the next 10 minutes, what I have, I want to catch up on this part, which will help you to understand the concept for your TSI. So here is the last two slide, or the last slide in this. In the whenever there is the amino acids are being used, the amino acids which are being used for the peptones, all the amino acids, before they can be used, it is hydrolyzed. So these are the amino acids of the peptones, and they are connected by this peptide bond, C double bond ONH. Before they can be used, the amino acids are separated out. And each amino acid, before it can be used, it has to remove this amine group. And that amine group is released as ammonia. And this carbon skeleton which is remaining, it enters directly into some of the intermediates of the Krebs cycle. So oftentimes this carbon skeleton, it directly enters into the Krebs cycle. And once it enters into the Krebs cycle, sometimes it generates many of these in the Krebs cycle. When it enters the Krebs cycle, there are many acid intermediate products are made. You see, there are many intermediate acidic products are made. And that's because if you see in your, this is the first time I saw in your, one of the experiments with the Proteus, I believe, it was with the Proteus, the butt was yellow colored, the slang was red in color. Am I correct? If I recall it correctly, and that was across the board, and like all the board section had the same result, which is very, it was very like kind of challenging for me also because I've never seen like that. And the only explanation what I can give at the moment is because the bacteria utilizes the peptone, those amino acid skeleton, it entered the Krebs cycle, it had entered the Krebs cycle, and the pH was enough for the pH indicator to turn it yellow. You see that? It turned it yellow, and that acidic pH for the intermediates of the Krebs cycle was more dominant than combined with all of these ammonia which is being made free. So this ammonia which was released and it was made free, that was not that strong, but the intermediates of the Krebs cycle were more dominant, and that's why you saw that yellow coloring of the slab and the red, the yellow coloring of the butt, but the red color of the slab. Which normally you don't see that because oftentimes this ammonia is the one that gets released outside the cell, it combines with the water and it forms ammonium hydroxide and dribbles down. And the very last thing in this part is, how about when the bacteria utilizes the lipids? The lipid catabolism is because, how about, I think you all have enough for the day. This I can leave it for. Yeah. Is that okay? Okay, I understand that part. Okay, folks. Hey, you had a question for me. Yes, Andrew. Yeah? Before the break, and I told you.
Yeah, it was just about the complex together manufacturing.
Thank you, Christine. Hey, don't forget your recorders and the phone, please. Does that help you?
It helps a lot.
Okay.
You're very fast. which is fine. But it helps to sort of look at everything again because I'm trying to write down everything. And I almost can't hear you because I'm trying to write. So then
But
when I
is it,
listen-
does it get recorded? Can you understand what I'm talking?
Yeah. Yeah. And then when I listen to it the second time, then I'm not having to focus on writing and I can just focus on
Thank you.
Cool. Thank you.
Appreciate it.